So just like last time we were discussing about the facilities and environmental condition of the laboratory. We discussed some of the conditions, just like we have the discussion about zoning and ergonomics and also scalability. So zoning, we prepare the zones in the laboratory, which one will be our working area, which will be our sample preparation area, which one will be our sample uh, storage area, and where will be the main equipment. So we do the zoning, so we can treat all those zones equally. For example, in your normal working area, just like you do the paperwork, you don't need a specialized uh, air facility or air circulation. But within your working area, it's very important that you should have proper air circulation. Either you have the air conditioning, just like we have in most of the laboratories, or you should have proper HVAC system so we can properly. So if you're, it depends on the type of laboratory. Either you can work with simple air conditioning facility or with proper HVAC system. So you do the and the other very important parameter that we discussed last time was the ergonomics. Ergonomics is like how you can work in a way that you don't get tired, you don't get disease. For example, how good are your sitting positions inside the laboratory? Are you bent more? Are you like stand doing work by while standing? So you can't stand for like 8 hours. So and also, what is the position of your tables? What is the condition of the light? These are all around the ergonomics. So it's like how user friendly is the environment inside the laboratory. As we discussed last time, in some cases, we get fatigue like after 2, 3 hours. And in some laboratories, we can work like for 8 hours and still we can feel fresh. So it ergonomics is all deal that how is the working environment, how conducive is the working environment. And this is also very much important for your good laboratory practices because if the working environment will be conducive for you, then you can perform the things in a much better way. And for the last time, where we were in the last lecture was about the water. This is very, very important because we add water in everything. If we have to like prepare the media, for example, are you going to grow, uh, for example, the tuberculosis? You know there is a specific TB media. Are you growing the cells inside the laboratory? For all those we use water. For all your machines, you use the water, and some of the water we in our laboratories we get the packed water that is of highest quality, and sometimes we should also check that quality or we have the system for deionization inside the laboratory, or we have the system for distilled water preparation inside the laboratory. So we have the like highest quality water because water is very, very important for all your operations. Either even if you are washing the reusable equipments, the water is important. I gave you the example last time about my car that I put the water from a pipe and there was algal growth inside and it got stuck inside and then I had to face problem for a long time. So what are different impurities found in water? So these are some of like biologicals which can be found in water. So in water, there could be bacteria. Even if like you can have the tap water, sometime because you are working in the laboratory, you have the nutrient agar place with you. So sometime what you can do, you can take 100 microliter of water and you can plate on your nutrient agar plate, and then you can incubate for 24 hours. The next day, you will find different kind of colonies on that. So nutrient agar, is rich media. It can grow both bacteria and fungi. So if you have to like check for fungus as well, so you can put like for another 24 hours. It's better to check after 48 hours. Then you will have like a good number of bacteria and fungi. They will be growing on your plate, and then you can have an idea. One of the thing is very important. We should like have a proper check on the water, especially if you are getting the water from the government supply. If it is not the boring water, for the boring water mostly is free of contaminants. But sometimes there could be contamination. But if the water is like flowing, for example, in Rawalpindi area, what we are getting water from the Khanpur Dam. So from the Khanpur Dam, there is a pipeline who brings the water in Rawalpindi, and from there it is circulated to Pindi areas after filtration. So that water is passing through the pipes, and sometimes there could be leakage and it get contaminated. So it's important that we should know what kind of supply we have. For example, in our university, for example, I'm right now in NUST. So in NUST, they have their own borings and their own circulation system for the water. So they transport the water. So we should know the sources. So in some cases, there is a chlorination of the water that also, if it is chlorinated, then it can also hinder like some of your results. For example, if you are going to grow the bacteria and you are going to like prepare a media, for example, you are going to prepare nutrient agar, the water supply you are getting is chlorinated. So you are going to prepare the media in the chlorinated water. You take the water, prepare the media, and then you try to grow the bacteria on that. So bacteria will not grow because the water is chlorinated. And this is how it can definitely. So this is how like you have to be sharp enough to identify what is the reason why my bacteria are not growing. So this is how, that's why we always like use the negative control and positive control to identify the things what's wrong. So we can have like a bottled water, we can have the supply water, and then we can have a comparison that either the water is chlorinated or not. So this is just one example. You should have an understanding that what is the source of water, from where water is coming, either it's contaminated or not. It's always like good in all your laboratories. You should check the supply, and for that supply, you can just use like 100 microliter of the water, and you can spread on the plate. And then you can like for 24 hours, you can check for the bacteria, and for 20, like if you grow further for 24 hours more, you can have all the fungus in that water. So this is how you can check the number of contaminants, and even like you can also you have like a method of serial dilution, and this is how you can exactly count the number of microorganism in that 1 ml of water. So the natural contaminated contamination could be in the water that you are using in your laboratory. It's better to check what kind of contamination we have. So mostly like if we can check for the bacteria. So unit of measure for the bacteria, we use the cuneiform unit CFUs per ml, and I'm sure during your MLT and during your degree, you know the method that how you have to count the cuneiform units per ml. So you can like, if it is less number, definitely, for example, if I'm taking 100 microliter and I have 10 colonies on my plate, it means 100 microliter contain 10 bacteria, and that means per ml it will be 100 bacteria per ml. And if the number is in like millions and billions, then you do the serial dilution. So you take like 1 ml water, then you can take 5 or 6 different microfuge tube, and you can add 900 microliter of water and take 100 microliter from tube one, and this is how you do the serial dilution. And this is how we can prepare like the contaminated water may contain 1 into 10 raised power 6 or 1 into 10 raised power 7 uh, CFU per ml. So this is how we actually try to know the contamination level, and it's important for your laboratories that you should have an idea about the contamination in the water. Then we can have like pyrogens. I'm sure you people are very well aware about these pyrogens. These are not the bacteria itself, but these are the components of the bacteria that could be toxic. These could be the toxins. So these can also be there, and they can definitely, if you are in a microbiology laboratory, then they can affect the results. So we also check for the pyrogens. So these include like the bacterial cell walls, can retard cell or tissue growth. So this is like I was also mentioning to you. So these are not the cells itself, but in some cases we treat the water, and that water is free from microorganisms because they are
Naglagan pa sila Rodi.
these are clear.
Nagkatlagan pa sila Rodi. Nasa mano na paligid.
So I don't know who is this, who is there, but okay. So let me So we were discussing about these pyrogens. So these could be these could be the contamination. So sometimes we treat the water, so bacteria are killed, but their components are still there, and they can definitely affect the results. So that's why, just like we do the LOL test in our preparations of some of the drugs inside the pharmaceutical units. So for the pharmaceutical unit, we do the LOL test, and LOL test is used for the pyrogens. And this is very, very important as all the like injectable we use in the veterinary side, all the things we use, we prepare, we do the LOL test so we know the presence of it's not the bacteria itself, but it's the component that can just like we can have the cell wall, and the cell wall could also be toxic. Another thing that could be inside the water could be these nucleases. So enzyme that cleave bonds within nucleic acid. In some of the water that you can use, for example, even if you are handling the water and if you are handling the things, the cells from our hands, if you are not like putting the gloves, the cells can go inside the water, and cell inside the water, it actually get the water inside and then it's explode. So water is more pure. So and there are more salts inside the cell. So in order to neutralize, the water goes inside the cell and it explode. And when the cells explode, they release these enzymes. These could be proteases. These could be nucleases. So the water could be contaminated with these enzymes. And if you are going to use that water for PCR, for example, then you will get the false negative because the sample could be positive, but it could be degraded due to these nucleases, due to these proteases. Sometimes your reaction even don't work. So that's why you have to be very careful what kind of water you are using. So you can imagine, like even if we talk about the simple water, it can like contain in the next slide you will learn these particles could be there, and there could be bacterial contamination, there could be viral contamination, there could be fungal contamination, there could be the component of cells in the form of pyrogens, and the water can also contain different enzymes that can hinder the results. And so other purities that could be found in the water could be particulates and colloids. So no, these particles could also be there. That's why even for the drinking water we drink, we calculate the TDS values. So what are the number of total dissolved solids inside the water? So that's also very important that we should have an understanding that either there are particulates inside, and even like for the sometime if we have water is coming from the boring. We put the uh, iron pipes, and then there could be rust, and those particles could also be there, and they like the rust and the other. Sometimes we see the impurities, but sometimes those metallic impurities we don't see, and they are there inside the sample, and they can definitely affect the result. So you have to like very very careful. You should have like proper check, and after it's better as usual you can as frequently you can check the water supply, what quality of water you are getting. So it's like you can simply have a TDS meter in our you can simply have the now we have the small meters. In the next class probably I'll show you, I have those meters with me as well. So what you can do, you can have those meters, and with those meters you can check the quality of water. So what is the number of TDS, what is the total ion concentration, what is the total salt concentration, how much what is the resistivity of the water, what is the conductivity of the water. So we can check all those parameters. Uh, next in your chat you can have to explain to me what are the colloids and how we can remove colloids from the water. So this is your one simple assignment to all of you who are listening this lecture. So you have to briefly, 2 3 lines, you have to explain in the chat of our group discussion about the colloids. Then another very, very important parameter could be the dissolved gases. The water can be rich in like nitrogen, oxygen, and carbon dioxide. So these gases could sometimes, like if we are getting the water, There could be microbial activity inside. We can put other things inside, so that result in the production of different gases. For example, even like from the microbiological activity or from the other activities, you can have an idea, like from the fish pond, for example. So in fish pond, there is a lot of activity going on. The water could be rich in carbon dioxide, that could be rich in oxygen. If there is more algal growth, it could be rich in oxygen. If there is less algal growth, it could be rich in carbon dioxide, because microbial activity is going on. So that can also release ammonia, they can release nitrogen. So that water, it depends on the supply of the water. So water can have all these things inside. Just like I mentioned, it can have dissolved gases, it can have enzymes, it can have particles, it can have colloids, and it can have pyrogens. So you have to like very carefully. This is just one example for your good laboratory practice. It's just if we talk about the water, you have to check the supply. So you're like entirely, if you are working in a microbiology laboratory, if you are working in like doing all time pathological studies or hematological studies, so your studies could be affected, your results could be affected if you are not using good quality water. So just one parameter is the good quality. So for a good laboratory practice, you have to check everything, like temperature is good inside the laboratory. For the storage, the temperature is okay. Some of the things you can put at room temperature, some you have to put it 4 degrees Celsius, some you have to put at minus 20 degrees Celsius, some of the things you have to put at minus 80, other you have to put in liquid nitrogen. So everything, that the temperature is one bigger parameter, water quality is another big parameter, light. So some of the chemicals we don't have to expose to the light, and some of the chemicals they are okay at like light we are exposing. So all these things are very, very important, and you have to take care of all these things. So in the next slide, we are going to briefly discuss different technologies used to purify water. So these are some of the technologies that we are using in our laboratories so we can purify water. For example, one of the things is reverse osmosis. So this is, I think, you are very much familiar about this reverse osmosis technology, in which we use the membranes and we try to purify the water using those membranes in the process of reverse osmosis. That's called the RO water. We commonly use the RO water in our laboratories. It's like it's a simple technology, you know. Even household they are using now the RO water. You know, there are filters. They say you can put those filter with the RO membranes, and then they can purify the water. So they remove all the ions in the water, and you can have, for example, the TDS value of your water, which is like being supplied to you in your laboratory. The TDS value could be 700. So 700 is too much, and that you can't use for your laboratory operations. So what you have to do, you have to pass through the water through the reverse osmosis, and with the reverse osmosis, you can remove all those ions, and then after like your RO process, you can have the TDS value of 0. I have like in my own laboratory, I have a unit installed of RO. So normally in a daytime, I can like produce around 1,000 liters of RO water so that I can use in the laboratory. So that is of different capacity. Just you give you an idea that we can have RO unit like that can produce 50 liters of water, or we can have a RO unit that can produce like 3,000 liters of water or 5,000 liters of water. It depends what is the consumption. Even like you can sell that water. For example, one of our colleague Rizwan is from Gojra, so I'm not sure that from where you are getting the RO water. But if you have a unit installed, you can provide the water to all the laboratories. So this could be another business for you. Another thing that we use is the distillation. So you know there is a distillery. It's kind of a distillery. So we heat the water and we produce the vapors, and then we condense those vapors and collect those. So even it's a better version of water than the RO water. So it's like it results in loss of lot of water, but the purity of water is even better than the RO water. So we sometimes we use double distilled water. So in order to like fully, uh, like if you're very concerned about the results, then you can use double RO water, double distilled water. So RO, and then again you do the RO, and then you can have it the best quality water. So we can use the reverse osmosis. We can use the distillation. I'm sorry. Another is deionization. So deionization, just like the terminology says, so we remove the ions. So in everything, in all the water, we have the ions that can affect the results. For example, the sodium chloride. When it's inside the water, it's sodium and chloride ions. And with the deionization, we remove those ions. So that's another way in which we remove the ions from the water, and we can have highest quality water. Then we can use the process called filtration. So there are hundreds of different kind of filters. It depends on what kind of impurities are there inside the water. For example, if like there are particles and colloids, we can have simple filters installed. They could be of any material. So we can remove the particles and colloids, and then we can use another RO filter or different kind of filters. So it depends what kind of contamination is there. Accordingly, sometimes we pass the water through the charcoal filters. So charcoal, activated charcoal. For example, you are working in a laboratory and you are using ethidium bromide, which is toxic. So in order to remove the ethidium bromide, we use activated charcoal filter. The another method is called adsorption. So with adsorption is like we have the ions and then the other ions they binds to those material and then we can have the water. So that's another way. Then there is a process called ultrafiltration. So ultrafiltration is another way in which we have used the multiple filters to remove all kind of contaminants from the water and we have the purified water. And the last is the UV oxidation. So we use the UV light that kills the microorganisms. So in our even drinking water units, we have the UV light installed. So we are left with 1 minute, so I should quickly finish it this lecture. So for the water, even we have to do the risk assessment. So water purification system, we mostly use the deionizer in our laboratories. And if we are using this machine, we can get the electric shock. And sometimes, the deionized water is not suitable for drinking. So you like maybe thinking that this is of highest quality water, I should drink it. Even it can cause shock and death. So you should be very, very careful that there are always risks and you also have to do the risk. Although we had a plan that we should have a workshop on risk assessment, but unfortunately, now we might not be able to have. And then waste management and disposal protocols are very important. We had another lecture that we should have. We normally have the hazardous waste, and we have the biohazard waste, and then contaminated waste, and there is a proper way. I'll share these slides with you. And then there is a monitoring and environmental condition, maintaining the environmental. We have discussed in detail about like all the environmental condition, is air, water, light, and all these things. And we should properly check all these parameters, and we should maintain it. And then there is a like continuous improvement and compliance. So whatever is the requirement, we should have to be like